This video is factoring by grouping. So if we look at example 1, what I notice first is I have x cubed minus x squared minus 25x plus 25. If I notice, I have 4 terms. Therefore, I'm going to group them together and factor by grouping. Okay, I group the first 2 terms together. I group the second 2 terms together. From here, I look for what's in common. So if I look at my first group right here, x cubed minus x squared, okay? If I look, I have an x squared in common, so I'm going to factor that out. So what that looks like is I have my GCF of x squared, and then what do I have left? X cubed divided by x squared is just x. Negative x squared divided by x squared is a negative 1. Okay, I'm going to do the same thing on the second side. Okay, so I'm looking at these now. I have negative 25x plus 25. Well, we notice they're both divisible by 25. If in the second group, this number right here is negative, I'm going to divide by a negative number. If it's positive, I divide by a positive number. Okay, so I'm going to factor out a negative 25. So my GCF, negative 25. And then I divide negative 25x divided by negative 25 is a positive x. 25 divided by negative 25 is a negative 1. From here, what I notice is I have x minus 1 and x minus 1 in parentheses. This is my greatest common factor for this whole group. So I'm going to write it just one time. And then I need to write down what I have left over. So from there, I have an x squared and a negative 25, and I'm going to put those together, x squared minus 25. Okay, if I look at x squared minus 25, what I notice is both of them are perfect squares, and I'm subtracting. Okay, that's called a difference of squares. Okay, so in order to be a difference of squares, both numbers have to be perfect squares, and it has to be a difference, which means subtracting. So this right here is a difference of squares. So I can keep factoring. So in order to do that, I draw my 2 sets of parentheses. I take the square root of x squared. I get x and x. I take the square root of 25. I get 5 and 5. 1 plus, 1 minus, and then I bring down my other factor of x minus 1. So this is how you factor it. Okay, we're going to do another example. I have x squared, or sorry, I don't have x squared. I have x cubed minus 2x squared minus 9x plus 18. From here, I look, okay, at all 4 of my terms. There's nothing in common that goes into all 4 terms, so now I can factor by grouping. So I group the first pair, I group the second pair together. Again, I look for, in my first pair, the GCF, the greatest common factor. I notice it's x squared. So my GCF goes on the outside. I write down what I have left. X cubed divided by x squared is x. Negative 2x squared divided by x squared is a negative 2. Looking at the second one, right here, I notice that this is negative, so I'm dividing by a negative number. And then the GCF would be 9. So I'm dividing by negative 9. So I put minus 9 here, and I write down what I have left over. Negative 9x divided by negative 9 is x. 18 divided by negative 9 is a negative 2. My goal is to have the same thing in the parentheses. Okay, so I do have the same thing, so I write it down once. It's my greatest common factor. And then I need to write down everything I have left. So I have an x squared left and a negative 9 left. I put them together. Okay, x squared minus 9. If I look at it, the x squared is a perfect square, and it's a difference. So I can keep factoring because this is a difference of squares. I'm going to draw the square instead of writing it out. Difference of squares. So, oops, I have x and x because I take the square root of x squared and get x and x. Then I take the square root of 9. Square root of 9 is 3. And 3. I get 1 plus, 1 minus. And then I bring down my x minus 2. Again, in order to factor a difference of squares, both terms have to be perfect squares, and it has to be a subtraction sign. So if I have one number that's a perfect square and the other one's not, I cannot do a difference of squares. Okay, looking at example 3. I look at all my terms. Okay, they look mostly to be divisible by 2 except this one, so I can't factor out anything. So then I pair my first two terms and my last two terms together. Okay, I look for what they have in common. In the first group, they have an x squared in common. So when I factor out an x squared, I get a 2x plus 1. Again, if I were to multiply it out, I have to get what I started with. If I look at the second group, I can factor out a 4, a positive 4 because that's positive, so plus 4. And then I look and I'm left with a 2x plus 1. Again, what's in the parentheses has to be the same. So I write that down once. And then I take what's left over and I pair them together. I get x squared plus 4. If I look at this, I get x squared plus 4. That's not a difference of squares, so I am done. Okay, one more question. I have example 4. If I look at all 4 terms, I have, each one has an x, so I'm going to factor out an x first. So when I do that, I get, and I'm going to use brackets, so I have 4x cubed minus 20x squared minus x plus 5. And again, I'm using brackets. So then I'm going to group my first 2 terms, my last 2 terms. Okay, this first group, they have a 4x squared in common. So I get 4x squared, and then I write down what I have left, which is x minus 5. Can't forget my GCF out in front. From here, doesn't look like they have anything in common, but I need it to be x minus 5. So I'm going to divide by a negative 1. And I get x minus 5. That negative 1 changes the sign but doesn't change the numbers. So I have x minus 5 in common, and then I put these two together, 4x squared minus 1. I still have that GCF out in front. From here I can look, that's a difference of squares. They're both perfect squares, so I keep factoring. So I get 2x plus 1 times 2x minus 1. I still have my x minus 5, and then that GCF out in front. So this is what it would be factored completely. So this is how you factor by grouping.